Okay, so this is part 3 of 8-3 in your textbook, the section on hypothesis tests for the proportion. So I have 2 more examples for you. Dog ownership. A humane society claims that less than 35% of U.S. households own a dog. In a random sample of 400 U.S. households, 156 say they own a dog. At the alpha equals 0.10, is there enough evidence to support the society's claim? Okay, all about that claim. So we're going to start with identifying the claim. A humane society claims that less than 35%. So the claim, as a math sentence, the proportion is less than 35%. Okay, so I've taken those words and turned it into a math sentence. Claim, P for proportion, less than 35%. The first thing I want you to notice with this claim is that there is no equal sign in the claim. Do you remember the rule that the null hypothesis must have the equal sign? So when I write the null hypothesis, I can't just add an equal sign to that. I actually have to use the opposite of this. So I'm going to use greater than or equal to 35. And that puts the equal sign in the null hypothesis. So if you cannot use the claims inequality in the null hypothesis, you have to use the opposite that includes the equal sign. So a very important thing just happened here that you need to watch for. So when you write your claim down, if the equal sign is not in it, it cannot go into the null hypothesis. It has to go into the alternative. So the alternative hypothesis then will match the claim. Notice that the numbers are all the same, but the alternative hypothesis is now matching the claim. So there we have those that are very important to our success here. So I'm going to gather all the important information that I need for the formula. There's a P sub 0, that is the proportion from the null, which is 0.35. We also need the Q sub 0. Okay, if P is 0.35, then Q is 1 minus 0.35, or 0.65. We need the information from the sample. So there was a random sample of 400, n equals 400, and 156 say they own a dog. So that's our X. We're going to use those 2 numbers to find P hat, which is the sample proportion. 156 divided by 400. And that's 0.39. So that's our P hat. We do know that we are given an alpha of 0.10. And I will get to what the Z is in just a moment. Now I'm going to draw the curve. So this basically is step 1. Step 2 is to draw that normal distribution curve, 0 in the middle. Because of the inequality in the alternative, okay, the inequality in the alternative determines whether this is a 1-tail, 2-tail, left tail, right tail. This is a left tail because of the inequality. So we know we have a reject region to the left. Now it's time to find what that critical value is that is associated with this 0.10. Because we know we have a 2-tail problem, we can look at the table. 2 tails, 0.10. Yes. It is 1 tail. I'm sorry. It's 1 tail? I might have said 2. I meant 1. All right, 1 tail. So 1 tail, 0.10, and all the way down to the bottom. So 1.282. Again, I went to 1 tail, 0.10, and all the way down to the bottom. and it's negative because it's on the left. This is our critical value. So our Z, that is the critical value, equals negative 1.282. All right, so this begins our reject region. Yes? It's to the left because of the less than sign. If this were a greater than sign, then it would be over to the right. If it were a not equal to sign, what would we have?
Oh.
Two tails, correct.
So if you're judging which tail sign it is
by the alternative, the inequality in the alternative, yes. A lot of little rules for this procedure. Okay, so we finished step 1 and step 2. Step 3 is to calculate the test statistic. Remember, the formula for the test statistic is on that example that you can use on the quiz next time, but it's also on your reference sheet. So we have p hat minus p sub 0. I'll go ahead and write it here. All over the square root of p sub 0 times q sub 0 over n. So filling in these important pieces, p hat is 0.39 minus 0.35 divided by square root 0.35 times 0.65 divided by 400. Remember, if you're doing this all at once on your calculator, you should put parentheses around the numerator. So we'll go parentheses. And that gets us a 1.68. And it's positive. Notice that it is positive. I looked twice when I saw that that was positive, because our reject region is over on the left, and I had to look twice, but it's because the p sub 0, the p hat is bigger, 39% than the 0.35. Okay, so it kind of just verifies. Just want to make sure that it matches. All right, so that 1.68 is positive, and that means it falls somewhere over here. It is not in the reject region. Okay, not in the reject region. So we are going to fail to reject the null hypothesis. Since 1.68, and you really should say Z, 1.68 does not fall in the reject region, the null hypothesis cannot be rejected. All right, that's sentence number 1 you need to write. Sentence number 2 is going to be about the claim. So first of all, you take your failure to reject and you look at this null hypothesis. Okay, we're not rejecting this. We're keeping this, that it's greater than 35. But our claim says less than 35. So what does that mean about the claim? What are we going to have to do with the claim? The claim has to be rejected because we're accepting the null, and it's not the same as the claim. We're accepting the null, so we have to reject the claim. So what that means is that, going back to the birth sentence here, the Humane Society claims that less than 35% of U.S. households own a dog. That means they're wrong. We have evidence to suggest that that claim is not correct. Okay, and you can even write it that way. There is evidence to suggest the Humane Society's claim that less than 35% of U.S. households own a dog is incorrect. And that is a full problem. Took me a whole page because I'm writing large, but you should expect to take up some room with these problems. Yes.
For the second sentence,
Yeah.
when it's coming down to the same, like, what exactly are you stating in that?
Okay, so what I did was I realized that I could not reject this null.
Yeah.
And it's opposite of the claim. So since I'm accepting the null, that means I have to reject the claim.
Okay.
So you're saying that the Humane Society's claim is wrong.
Okay.
And you can put it in whatever words you want as long as you include everything about the Humane Society and their claim. So this is a special case when you end up having two different things happening. You fail to reject the claim, the null, but you reject the claim. You have to watch for that. And it's happening because of the fact that the inequality in the original claim did not go into the null. So it can happen either way, though. You have to be careful about the how you set up your original hypothesis, null hypothesis, and the claim. Can I show what? This one? Yes. You can read that. There is evidence to suggest the Humane Society's claim that less than 35% of U.S. households own a dog is incorrect. So basically they're saying the 39% that we got in the sample is statistically bigger than the 35%. All right, ready for another one? Just one more. And this is about smokers. All right, a medical researcher says that less than 25% of U.S. adults are smokers. 25%. In a random sample of 200 U.S. adults, 18.5% say they are... Okay, well, I don't want that to happen. It says I have 13 minutes. Bet I can finish it before 13 minutes. But that little thing's probably going to come up again. All right, shouldn't take me 13 minutes. All right, so the medical researcher says that less than 25% of U.S. adults are smokers. In a random sample of 200 U.S. adults, 18.5% say they are smokers. At the alpha equals 0.05, is there enough evidence to reject the researcher's claim? All right, let's go with the claim first. Less than 25% claim. No equal to sign in that, so the null has to have the opposite, which will be greater than or equal to. And the claim itself will go into the alternative. Claim goes into the alternative because the equal sign is not in it. If the equal sign is in the claim, it will go into the null. Okay, so our null proportion is 0.25, making our Q 0.75. Our p hat is given this time, the 18.5% or 0.185, and n is 200. Our significance level is 0.05. That's step one. Step two is the curve and the reject region. Because it's a less than, we again have a left tail problem. Left tail because it's a less than. Now we'll look for that critical value z. One tail, 0.5. On the table, one tail, 0.5, all the way to the bottom. 1.645, and it's negative. Step 2 is done. Step 3 is the test statistic, also called Z, and it is P hat 0.185 minus P from the null divided by P from the null, Q from the null, over 200. Again, when calculating, losing batteries all over the place, put parentheses. Negative 2.12. This time it's a negative. And that falls way out here in the reject region. So clearly we are going to reject the null. So it's the test statistic falls in the reject region. The null hypothesis is rejected. Okay, looking at our null, it says greater than or equal to. We're rejecting that. So that means we have to accept the claim because the claim is different. So again, we have two opposite things happening. We're rejecting the null, but because we're rejecting the null, that means and the claim is in the alternative, that means we have to accept the claim. So we are going to accept the claim that a medical researcher has made saying that less than 25% of U.S. adults are smokers. The claim from a medical researcher that says less than 25% of U.S. adults are smokers is accepted. Any questions there? Okay.